All right, good morning, ladies and gentlemen. This is Dre CZ. Okay, I would like us to do some practice questions on quadratic functions. Particularly, who wants to know how to complete the square. Okay, so I'm going to use typical examples, and hopefully, if time allows, we can actually do an example on piecewise functions. All right. So let's assume that you have been given these functions. Alright, so you are asked to complete the square. Now, what I want you to also understand is that there is a difference between an expression and an equation. Okay, so what is an expression? Whenever you have a function or a function that is written without an equal sign, there's no number after the equal sign, then you know that's an expression. Whenever we equate this particular function to 0 or any number other than 0, then it becomes an equation. Okay, so how we treat an expression is different from how we treat an equation. Okay, so if you are dealing with an expression, first thing first, completing the square method, we are told that the coefficient of x squared should always be 1. So in this case, here it's already 1. Okay, so now what do we do after that? So since it's already 1, what I'm going to do simply is I'm going to ensure that I pick one of the x's. So I'm going to say x. Then I'm going to pick the sign as it is. So it's minus. Okay, so now I want half of the coefficient of x. In this case, half of 2x. So half of 2. So whatever we multiply by half becomes half. Okay, so half times 2 is 1. So the half of 2 is actually 1. So we have 1 here. So that's what I'm going to write. Then I'll square, then I'll subtract. Whatever value is here with its sign, that's what I square and subtract. So negative 1 squared. Then I'm going to say plus 6. Okay? Then we have x minus 1 squared. This is plus minus 1 plus 6. So we have x minus 1 squared plus 5. Right, so I've completed the square. Okay, it is as simple as that. Let's look at another example. Okay, so assuming this is the quadratic equation that we've been given, so how do you deal with such a quadratic equation? Okay, so in this case, what you need to do is, you simply are going to say the same thing. So write the equation here. So the new equation is f of x is equal to 3x squared plus 9x plus 3. So we want to ensure that this is 1. So we're going to factor 1. Now, for me, I'll only factor out the 3. So now, what you need to know is whenever we are talking about factoring out, that is actually division. Okay? So anytime you hear factor out, you are dividing. Okay? So this is an expression, this is not an equation. So I'm not saying divide 2 out by 3, no. I'm factoring out a 3. Okay? So I'm going to factor out a 3 only on the 2 variables. So the first one, I'm going to say 3. Then when I factor out the 3, what remains here? You're going to notice that we have x squared there, then we have plus. If you factor out the 3 here, it's like you're dividing 9 over 3, which is actually 3x, then plus 3. Then I'm going to do the exact same thing I did before, right? So I'm going to say 3, I'll pick 1x, okay, plus, because the sign here is plus. What is half of 3? So half of 3 is like 3 times 1 over 2. So it's 3 over 2. So I'm going to put 3 over 2 here. That's half of the coefficient of x. Then I'll square. Then I'll say minus. Okay. So say minus the very thing which is here squared, then plus 3. Okay, take note how I'm putting the square brackets, it's very important. This 3 affects whatever is in here. Okay, so we have 3 x plus 3 over 2 squared minus 9 over 4 plus 3. 3 times this is 3 x plus 3 over 2 squared. Okay, then we have 3 times this. This is going to be 27 over 4. Then I can now open plus 3. Alright, so what is 4 times 3? So this is a mixed fraction of some sort. So 4 times 3 is 12. So this is saying 27, negative 27 plus 12. Okay, so now since instead of addition because of the minus, so it's saying this is 5, this is 15, so this is actually negative. The numerator becomes negative 15 over 4. Alright, so I've completed the square for that question as well. Let's do maybe a third example over the same. Okay, so one, completing the square. This is all we are doing today. Okay. Okay, so this is all we are doing today. So this is how you go about these questions. Alright, so let me continue. Okay, let's look at maybe a different set of questions. Okay, let's look at different set of questions. Let's assume we're looking at the same question. Now, whenever you hear a question that asks you to leave your answer in this form, this is actually asking you to complete the square. Okay, so if you have a question that is in this form, this is actually asking you to complete the square. Alright, so this has actually been left in this form. So in this case, what is A? A is 3. If you look at P is actually negative 3 over 2. Now, notice it's positive here. There's a negative, so meaning that for it to be positive, then this one must be negative. Okay, negative times negative is positive, so it's the opposite sign. Then we have Q and negative 15 over 4. Okay. So completing the square is very important because it's a wide application when it comes to quadratic equation. So you will be asked to sketch a quadratic equation, but you can actually derive the turning point, the maximum value, from actually this very one which you complete the square for. Okay, so erase this. Let's try maybe a question that has a negative. Okay, so you've been given this question and you are asked to complete the square. So how do we do that? First thing first, we need to ensure that the coefficient of x squared is 1. So here, what I'm going to say is we're going to actually factor out the negative 2. Remember, factoring out is like dividing, so negative 2 out there. Then what remains? X squared. Now, what number is here? It's a 1. So half of 1 is half, but is what? A negative. So this is half. Okay, x minus 4, right? Then we're going to say we need the half of this. So I'm going to say negative 2. I'll pick 1x as before. What sign is here? Negative. What's half of 1 over 2? That's 1 over 4. Remember, whatever we multiply by half becomes half. So this is where the 1 over 4 is coming from. Then I'll square, then I'll subtract this very number here with the sign squared. So negative 1 over 4 squared. Then we have minus 4. Okay, so from this, what else can we actually talk about? So you actually notice that we can actually evaluate that. So doing that, we have x minus 1 over 4 squared minus 1 over 16. Then everything minus 4. I'm going to distribute this, so we have negative 2, x minus 1 over 4 squared, negative 2 times this is plus 1 over 8. Remember, negative times negative is positive, minus 4. Then this is 8 times negative 4 plus 1, so 8 times 4 is actually 32, negative 32 plus 1 is negative 31 over 8. I've completed the square. Okay, so based on this question, if I'm going to leave it in this form, what is A? A is actually negative 2. What is P? P, since it's negative already, so it's actually positive, so it's 1 over 4. And what is Q? Q is negative 31 over 8. Okay, so now the turning point can actually be found by saying P comma Q. Okay, so in this case, what's the turning point based on this example? The turning point is actually going to be 1 over 4 comma negative 31 over 8. Okay, and what does the A do? Now we were told, what we know is whenever the A is greater than 0, then the turning point is actually known to be a minimum. Okay, if A is less than 0, then this turning point is actually a maximum. So here, since our A is equals to negative 2 and negative 2 is less than 0, then this 1, 4, negative 31 over 8 is a maximum turning point. Alright, so that's the application. So whenever you have this is actually very effective, especially if you are actually asked to sketch a quadratic equation. Alright, so I think that suffices it. Now, generally, this is how we complete the square. So I've done an example on the positive numbers when we have a coefficient of 1 on the x squared variable, when you have a coefficient greater than 1 and positive, and when you have a coefficient with a negative. Okay, so that is how we actually work around these things. Okay, so what happens now if you have x squared minus 9 as your function? And you are asked to complete the square for this. What do we do? So in this case, the best way to do this, actually, I will complete the square for you, but I want you to see that it's not necessary to do the whole process. So you know that you can't see it, but it's 0x, right? So if I factor out the x, so here it's already 1, so I'm going to pick 1x, then plus 0 squared, then I'm going to subtract 0 squared. Remember, we said we pick 1x, then the sign is positive, then half of 0 is still 0, that's why it remains 0 squared, then you subtract whatever is here squared, so 0 squared minus 9. This is actually x plus 0 squared minus 9. I've completed, okay? So I could have actually skipped this. Whenever you notice that you have a function that is in the form x squared minus 9, so where the x, let me say, the coefficient of the x is actually 0, or the variable with the power 1 is actually equal to 0, then here you can actually move direct from this process to this. all you have to know is that this is always going to be plus 0 squared, then either minus or plus the constant. Okay, so that's how we deal around these questions. Okay. Lastly, okay, so that suffices the tutorial. So this tutorial is specifically just targeting on completing the square. Remember, completing the square is not as tedious as it looks. All you just have to know is the basics. Okay, so what was the basics? We said number one, you have to always ensure that the coefficient of the squared powered variable is actually 1. Okay, so you factor it out. Then we said an expression is different from an equation. How you treat an expression is different from how you treat an equation. Okay, so we have to be sensitive on how we deal with such. Okay, so there is nothing more actually on completing the square that we can do. Now, as I said, the general application of completing the square is this. Okay, so the P here is also called the line of symmetry, and the Q is called the maximum or minimum. Okay, value. Alright, so it's important to know this because there are questions where you'll be asked to find the maximum or the highest point or the lowest point, the highest profit, the lowest profit. So here you just have to know that if I can actually be able to complete the square based on the question that I have, the Q there is my maximum or the minimum. How do we test? Remember, we test using the A. So the A, we said if the A is less than 0, what do you expect? This is a maximum. If the A is greater than 0, this is a minimum. Okay, so this is reference to the turning point. So this turning point which you have, from here we say the turning point is actually okay, so this is the turning point. So you can find the turning point from this. Once you completely, if you can effectively do this, then everything else will be straightforward. Okay, so now if you are asked to actually find not just the turning point, but what if you are asked to find the zeros? Okay, either the zeros or you can call them the x-intercepts. Okay, so to find the x-intercepts, we are going to equate these to 0. Okay, then we're going to solve for x. Alright, so this marks the end of our tutorial. Remember to subscribe and know that completing the square method is not as difficult and as complicated as it looks. Okay, have a good day.